I'm working on a new course called Practical Software Design for Python Developers, and it's going to combine 30 years of experience in one course. It's going to be about OOP, design principles, design patterns, and how things work differently in a dynamically typed language like Python. This week I started a chapter about metrics like coupling, cohesion, and locality of behavior. And I made a test recording. Now it's far from done, but it's starting to come along. I decided just to upload it. Not only does it give you a course preview, it also shows you my process, how I create these videos. After all this excitement with Python objects, you deserve some time to relax. So get a coffee, sit back and enjoy hearing about metrics. Most pieces of software start as small scripts. In the beginning, they are nice to work on. But due to changing or new requirements, they will grow, and with each new function and class, the system gets more complex. There will come a time when your sweet little Python script turns into a big monster. Now, you know this is the case when you start to experience two symptoms. I bet you know the first one. You change code and break stuff in unexpected places. This is known as fragile code. Now the second one might also be familiar. You want to extract some code to its own module, but you can't because the code is so entangled with other things, you are forced to let it stay where it is. And that is known as rigid code. A good software engineer prevents fragile and rigid code. But how can you diagnose the code to find the causes for such code? Well, there are metrics for this. They are coupling, cohesion, and locality of behavior. So, what do they mean? Let me start with coupling. Coupling can be explained with this sentence. You change one thing, and something that you don't want to change has to change with it. If that is the case, there is coupling. Actually, if that is the case, we speak of tight coupling. You see, coupling is measured on a scale ranging from loosely coupled to tightly coupled. If you guessed it, if a module is loosely coupled, it can be changed without changing other things. If a tightly coupled module is changed, it requires many changes in other modules. So coupling is always measured from one module to another module. In the previous chapter, you already saw that a module can be anything ranging from a function to a complete system. Coupling expresses how much information is shared between modules on a spectrum ranging from loose to tight. It will always be a compromise between writing practical code and pure theoretical designs. Now sometimes adding coupling to the system is even intentional, as you saw in the last part where subclass coupling was caused with inheritance. There are many kinds of coupling. Here is a list of them. Pauze om te lezen. The order is roughly from loosely to tightly coupled. Now perhaps you remember the first one from the previous chapter. Function add takes two arguments and uses both, nothing less and nothing more. The coupling from the function call to the function is optimal. This is known as data coupling, where a module receives exactly the required information. The second kind of coupling you saw was logical coupling, where two modules without a visual connection must change at the same time. With inheritance, the logical coupling was turned into subclass coupling. Here it is likely that critical changes in superclasses require changes in subclasses. During the course, all kinds of coupling will be demonstrated with examples. Now, let me ask you this. If data coupling is such a good kind of coupling, should the goal be to turn any kind of coupling into data coupling or even remove coupling at all? And the answer is no. There will always be coupling in software designs. Without coupling, just like these islands, each module would be a program in itself. The goal is not to prevent coupling, it is to achieve loose coupling with a thin line of communication between the modules. Loose coupling is what allows you to move code around and even swap out modules without major refactoring. It is also what makes new developers feel at home when they enter existing projects. And remember, that new programmer might be you when you open your own code from a year ago. So coupling is the kind and amount of information that is shared between modules. It is a metric to express the strength of the connection between modules. And before we dive in deeper, this brings us to the second metric. Here you are looking at a perfect example of cohesion. This spice rack has all the spices, This spice rack has all spices and nothing and only spice and nothing but spices. You always know where to find them. And also that you will find nothing else in this rack. But how quickly things can change. For example, in my kitchen, salt and pepper is always next to the stove. Any free space in the spice rack, is quickly filled with other stuff. And then, when I buy new spices, they sometimes even land on top of the rack. If you do not have a good system, spices show up in unexpected places. Where to find them? My kitchen system has two problems. 1. The spice rack has low cohesion because it contains other stuff than just spices. And 2. Some spices show up in other places. To find them, I must search in different places. This property is known as locality of behavior. So basically there are three metrics under your control: coupling, cohesion, and locality of behavior. Each metric can be answered with a question. How strong are the connections between modules? How well do things in this module belong together? And can I understand this functionality by looking at a single piece of code? The metrics are closely related. Pull on one end and the others must move with it. Software design is finding a good balance between these three metrics. Cohesion also has categories. It ranges from coincidental to functional cohesion and you will see examples of all of them. De description en example die staan hier nog niet in. Dit is een slide voor later. Locality of behavior only has a single category. Code is either localized in a single location or spread over multiple locations. I'll come back to this to explain what I mean with locations. In my kitchen, it is easy to increase cohesion and locality of behavior. I put everything where it belongs. All spices in the rack, the clock on the wall and the noodles with the rest of the food. As my mother would have put it, clean up your stuff. But of course, that might influence the coupling of the system. I cannot repeat this enough. Every change to this software design has consequences. So, coupling is the kind of amount of information that is shared between modules. Cohesion measures how well the things in a single module belong together. And locality of behavior is how much of you understand functionality by looking at a single piece of code. And now that we have that established, let's proceed with the next inheritance topic: abstract base classes. The course will be online after the summer. Stay tuned.